Okay, so here are the notes for section 5.4. You don't need to see my little face for this one because really it's still pretty early here. You saw I existed. So section 5.4 is complex fractions. Complex fractions sound scarier than they are, and they look scary. The whole idea is that you look at them and you panic. Don't do that. You don't have to. It's just division. Okay, fractions are meant to look scarier than they really are. So there's two ways to do this. What I want you to do is find the way that makes more sense to you. I will show you both. If you like the first way, use it all the time. If you like the second way, use it all the time. Either way is fine, but pick one that works for you and makes sense and stick to it. Okay, it will be much easier than going back and forth between them. All right, a complex fraction is just a fraction in a fraction. Okay, they look crazy, but they're not as bad as you think. So always first, make one fraction in the numerator and in the denominator if there are multiples. This has to happen first before any of this other stuff works. So at some point you'll go to do this and it will go wrong because you won't have one fraction. If you always do this for this first method, everything is easy street from there, okay? So here's how it works. Simplify the expression. Remember that a complex fraction, a fraction itself, like if I had 7, oops, I need a pen, 7 over 3, it's really just saying 7 divided by 3. That's all this says too. All this is saying, rewrite it. All it's saying is 5x squared divided by y, divided by 10x over y squared. That's it. Now it's just a division problem, okay? So to do a division of fractions, we change to multiplication and flip the second fraction and simplify. That's it. So let's see, I have 5 and 10, that becomes a 2. That x goes away, and I just have x left here. This y goes away, I just have y left here. So now multiply across, I get x over y over 2. That's all it is. Fractions are just division, okay? Try another one. You try this one, and I mean it. So pause, try it. Okay, I'm assuming you tried it. I'm gonna rewrite it as division. 18a cubed over b squared divided by 6a squared over b. Just write them the way the fractions appear. Now treat it like we're dividing fractions. Keep the first fraction as it is. Change to multiplication. Flip the second fraction, b over 6a squared. All right, now let's simplify. Let's see. B squared and b, this just becomes b. 6 goes away, 18 becomes a 3. A cubed and a squared, that's just 1a left there. And now multiply. I get 3a on the top over b. It's done. Look at you go. All right, but they're not always that kind, are they? So in method 1, simplify the top into one fraction. Simplify the bottom into one fraction. Then do what we just did back here, okay? So take them separately. Ignore the complex fraction to start. So I have 1 over 4x minus 3 over 2. Common denominator would be what? Let's see, I have a 4, an x, and a 2, so it would be 4x. So then the first fraction just stays the way it is, minus, let's see, I need to turn that into a 4 and an x. So I need to multiply the top by 2x. That means 3 times 2x is 6x. Okay, and make one fraction. So I get 1 minus 6x over 4x. Fine. Now do the second one. So I got, let's see, 3 over 1 technically minus 2x. Well, the common denominator would be 2x, right? So that needs a 2x, and that has a 2x. So that's going to stay the same, the second fraction. To multiply that to the denominator of the first fraction to 2x, I just multiplied by 2x. So on the top, I'm going to multiply by 2x. It's going to be 6x. So this guy becomes 6x minus 2 over 2x. All right, so now I can rewrite my complex fraction as something more sane. So I have 1 minus 6x over 4x. Just going to make sure I did everything right. And then I have, sorry, I'm looking for a mistake that I made. Do you see it? 3, 6x. Oh, I don't know why I made that a 2. It was supposed to be a 1. There we go. Over 6x minus 1 over 2x. Okay, now I'm just going to rewrite it as division. 1 over 6x over 4x divided by the second fraction, 6x minus 1 over 2x. Now we know what to do. We rewrite as multiplication. 1 over 6x over 4x times 2x over 6x minus 1. Okay, now look at it. What do you see? I see these guys. Let's see, the x's cancel, the 4 becomes a 2. 1 minus 6x and 6x minus 1. What's the difference there? Really, if I pull out a negative 1 out of one of them, they become the same, don't I? This one would become negative 1 minus 6x plus 1, negative 1, 1 minus 6x. So they become the same. So if I pull out a negative 1, then these two guys cancel. Okay? So multiply straight across. I get 1 on the top because there's nothing left, and a negative 2 on the bottom. It's done. Negative half. All right. Use that first method. Try it here. Pause. Think. All right. So first, take them separately. Do the first fraction. What's the common denominator got to be? Let's see. 9m and 3, so it's got to be 9m. So that first fraction stays, minus 3 times 3 would get me 9. And then m, I need an m. So 4, I need to multiply the top by 3m. Gets me 12m. So the first fraction is 1 over minus 12m over 9m. Let's do the denominator. That's 4 over 1 minus 3m. So it's got to be 3m. It's got to be the common denominator. Let me get rid of that. Okay. So if 3m is the common denominator, how do I turn that into, I need to multiply by 3m. So that gets me 12m. And then minus 1 over 3m gets me 12 minus 1 over 3m. Do you see this? So now let's rewrite. So we'll take our pieces. 1 minus 12m over 9m divided by 12 minus 1 over 3m. 12m. Where's my m? Sorry. So now rewrite as division. That's all it is. 1 minus 12m over 9m divided by 12m minus 1 over 3m. And now you know what to do. We rewrite that as multiplication, right? 9m, just take some writing, 3m. And then we saw a second ago, you see this. These two are opposites of each other, right? So I'm going to factor out that negative 1 at the start and switch my signs. So that's going to be 1 minus 12m. All right, now you can start to cancel. These guys, oops, that was a lot of line. Cancel. That guy eventually cancels with the 9m. So that becomes a 3. So let's see what's left. All I got is 1 and negative 3. So negative 1/3. It's done. All right, so that's method 1. Make one fraction on the top, make one fraction on the bottom, rewrite it as division, treat it that way, okay? Fraction divided by fraction. The second method is a little different. So in the second method, and if the first one works for you, go forth, okay? Don't hurt yourselves. In the second method, you multiply the numerator and the denominator of the complex fraction by the least common denominator of everything. You simplify, and you try to clear out the fractions as much as you can. So here's how we go. Look at the fractions. Let's see, this is over 1. That's got an x, that's got an x, that's got an x squared. So the biggest factor here would be x squared. So basically what I do is I take each fraction individually and multiply it by x squared. And what this does is it clears out the fractions. So let's see. There's nothing to cancel here. That top, that just becomes 4 times x squared. Minus, let's see, that guy can cancel. That just becomes x. 6x. And we have the bottom. Let's see, that guy can cancel. That just becomes x. So that's 2x. And over here, those guys cancel. Minus 3. Oh, look at that. So now we just simplify top and bottom. On the top, I can take out a 2x. So that leaves me with 2x minus 3. On the bottom, I have 2x minus 3. Those guys cancel. This comes to be 2x. You can watch the video again. That's the joy of this. Okay, so if that went too fast for you, rewind a little bit. Try again. Okay, try a second one. Look at all of the denominators. That's over 1. That's over 1. So I have a 1, I have a y, I have a 1, I have a y squared. So the biggest denominator here, the biggest factor is y squared. So I'm going to go through and multiply everything by y squared. Okay, one at a time. So the first one is over 1. That means I just multiply across. That becomes y cubed. Minus, let's see, y and y squared cancel each other. That's just 1y left, minus y. Over, that's really just y squared because there's a 1 on that guy. And then the y squareds cancel, minus 1. Okay, great. Simplify. On the top, I can take out a y, so I get y squared minus 1. On the bottom, y squared minus 1 is a perfect, or sorry, a difference of squares. Y minus 1, y plus 1. And look, that y squared minus 1 is on the top too now. So I get y minus 1, y plus 1, y minus 1, y plus 1. Those guys cancel, those guys cancel. All I'm left with is y. Either method would work here. And you can use whichever one you prefer. All right, let's try another one. Okay, we need to look at this one just because of what it means. So this is not as bad as you think it is. All a negative exponent means is flip. Okay, so really this is just a messed up way for them to write a fraction. I don't know why they do it like this in this book, but they do. So really this is just this minus this. Okay, on the bottom, it's really just 1 plus. Now notice here, the exponent is with the x. So the 2 stays in the numerator. 2 over x minus 3 over x squared. So they choose this crazy way to write this. But we're going to do exactly what we've been doing. So look, find the LCD, least common denominator. Let's see, I have an x squared. That guy's over 1. I have an x squared. It's got to be x squared. That's the most x's. So you're going to multiply everything by x squared. Everything. Got to do it to everybody if you're going to do it. And pay attention down here. You have numbers in the numerator. All right, so on the top, that becomes just an x minus, let's see, that goes away, 1. Okay, no big deal. On the bottom, that first term becomes x squared. Next, the x's there cancel, so plus 2x. Those guys cancel, minus 3. Oh, well, we can factor the bottom, so let's do that. Multiply to negative 3, add to 2, so it's a positive 3 minus 1, x minus 1, x plus 3. Over underneath x minus 1, we see what cancels, so then we end up with 1 over x plus 3. Done. Okay, not as bad as it looks with those crazy negative exponents. Okay, but they're trying to scare you. Don't let it work. So the same thing happens here. Okay, let's simplify. So all we do is shift the exponents around. If it has a negative exponent, it goes into the denominator. So rewrite the first one. It's b over c minus c over b. 1 over b plus 1 over c. All right, so now take a second and think about what the least common denominator here is going to be. It's b's and c's. So the LCD here has got to be BC or CB, same difference. Okay, so multiply BC. BC. My pen and my finger got confused. BC. BC. All right, so the C's cancel here. That becomes B squared. The B's cancel here, minus, that becomes C squared. B's cancel there, that becomes C, plus C's cancel here, that becomes B. That's all. So now factor the top. Difference of squares, B minus C, B plus C. Over C plus B is same difference as B plus C, right? Addition is commutative, so those cancel. I'm left with B minus C. All right. So let's do one more. This one is, let's see. Yeah, this one is worth doing. Okay, so look at the denominators. Remember, factor first. So this is W minus 3, W plus 3. Oh, I missed a parenthesis. Okay, so this is the least common denominator. Okay, so multiply the top and the bottom by that least common denominator, everything. It's gonna look crazy, but I'm gonna, you're gonna know that that's what's going on in each of these places, okay? So look at the first one. If this is the common denominator, I'm left with the W plus 3's cancel, so I'm left with a W minus 3. In the second case, the W minus 3's cancel, so I'm left with minus W plus 3. Let's see. On the bottom, I get W plus 3, W minus 3 here, because it's just a 1. And then they totally cancel at the other part, plus 9. Crazy looking, but not as bad as you think. So on the top, I get W minus 3 minus W minus 3. Well, that just simplifies to a negative 6. On the bottom, we know that this makes x squared minus 9, right? Well, minus 9 and plus 9 cancel. So I just get x squared. Or W, I guess it was W squared. I don't mean x, sorry. Get my letters wrong. A lot of stuff canceled there. All right, here's one last one for you to try. Same process. I will tell you that when we come to an answer, you get x minus 3 over x squared plus 1. Try it. See if you can get the answer. This is the last one for you to try. All right, from here, there is an assignment in your email. So read your email, do the assignment, okay? If you have questions, send an email and ask, or come see me before or after class on Thursday, but you need to try the work, okay? Good luck. I will see you Thursday.